Good day, everyone. So we'll continue from where um, we stopped last week, and for this week, we'll be covering setting up the Ethereum node and also understanding the requirements, um, and also how the architecture is for validators, or basically for um, the blockchain, the node architecture. So I believe we've all gotten the whole concept of blockchain, um, and how it operates, how it works basically. So I'm just going to continue from where my colleague stopped. So basically, setting up a node simply involves having certain type of softwares in our computer or in our machine or in our server, and these softwares interact with each other. Sorry, I just want to confirm, you guys, hope you all can hear me.
Yeah, we
Hello.
can hear you. We can hear you.
Okay. Okay, all right, thanks for the feedback. So I'll just continue from here. So basically, what's a node? A node is a node basically is a computer, right, that runs specific softwares, and for Ethereum they are called clients. So, and these softwares participate in the network. So basically they act as participants in the blockchain, verifying transactions and maintaining a copy of the blockchain. So this is important because it ensures that new transactions or blocks follows the protocol, follows the rule set by the Ethereum protocol. And an Ethereum node basically verify transactions. It just ensures that every transaction um, that comes into the network is valid and follows the protocol. It follows the rules set by the Ethereum protocol. So, for instance, it could be how the data is structured, like the data type. It could be certain rules in terms of how the clients interact with each other. So it also stores Node basic also stores a copy of the blockchain. So if you're running a node, simply means you have a copy of the blockchain running in your own system. So you're downloading those copy from the network into your machine, into your server. So the node basically stores data about the Ethereum blockchain. So it maintains the history of all transactions. It also ensures consensus. So um, so last week we were also introduced to consensus mechanism. So it's more like the way or the approach in which um, nodes agree, in which the system agrees. So nodes helps the network to agree on the state of the network. So and this allows, or this ensures that the process is secure. And also the nodes basically communicate in a peer-to-peer manner. So they they tend to communicate directly with each other. So this eliminates the need for a central server, a central authority that manage the network. So the P2P the P2P model of communication just ensures that the once any new node comes into the system, it's able to communicate with other nodes in the network. So it's just very easy. So if I have, when we go deeper from the architecture, we'll understand how all of this, how nodes basically, interact properly. So how they connect and how they communicate with other nodes in the network. But what does it mean truly to run a node? So so just like I said that a node maintains a copy of the blockchain network, and it has like a couple of functions like verifying transactions, storing the blockchain data, maintaining consensus. Um, so running a node simply means in your machine or in your setup, in your device, you have you have the copies of the blockchain sync in your own node. So what this means is that your node, the data in your node is up to date, is in line with the data in every other nodes in the network. So if for instance I want to identify or verify a particular transaction, when they check my own node, they should be able to find that data, as well as when they also check other nodes in the network. So so what this means is that for every node in the network, there is the same copy, more like you're having an identical copy of the data in in the device or in the hardware. So so basically it syncs your node with the entire history of Ethereum network, allowing it to verify any transaction or block. Also, your node also checks for each new transaction and block for their validity, and ensures that they all follows the Ethereum rules. So I just wanted to ask, are we following, or am I just talking? Like, are we getting the explanation, or am I moving too fast? I just want to be sure that I'm carrying everyone, like we are all moving in the same pace. If maybe there's any part you don't understand, I think it would be better to like speak up now so I can clarify and ensure that everyone is we are all in the same pace and all moving together. So I just want to like get that assurance. So are we
I wanted to ask a question.
okay?
Okay, so my question is because by your template it says stay synchronized, right? That is for a node. Is does this happen automatically, or you have to always do the refresh
Okay,
to
so
get
basically,
the latest data?
yeah, you don't need to refresh it. Once you have it set up, once you have those clients um, running or properly configured on your machine, it does the syncing, right? So like it just syncs, try to catch up with the peers or the boot nodes in the network. So it does that. You don't have to like refresh or press any button. Once you have your setup properly configured, it does that automatically. Okay, so
All right, thank you.
okay, you're welcome. So is there any other question or any other, maybe if you think I'm moving too fast, or you're missing out on some things, or there are like some key concepts or some words or terms that I've used and you feel like it's not clear, you need more clarity on that, I would be willing to go through it. just to bring us all on the same pace. So so I guess we are all following, right? So yeah, so when basically if you're running a node, it simply means you have those particular softwares, those specific softwares or clients installed on your machine, and they are performing these functions. Like they have a copy of the the blockchain history or transaction history, and they are syncing in the sense that even if new transactions or new data comes into the network, you'll not also be able to catch up. You will also download those data into your own storage. So locally, basically. So that's what it means to like to run a node. But I also want to clarify that running a node is different from running a validator node, in the sense that if you're running a validator node, you need to like perform some additional step, or you need to go a bit further. So but we'll get more into that clearly. So but I just wanted to point that out, because I'll also be saying some things around that eventually. So who should run an Ethereum node, or why should we consider running um, an Ethereum node or a node basically? So for sovereignty, so you need to like have full control over your data, over your interaction with the network, and um that's what you stand to gain if you run this node yourself. So when you run this node, you have full control over your interaction with the network, and you don't need to rely on any third party or any intermediary for your transaction. And another point is security and privacy. So when you're using third party services, so they can track your activity and collect your data. But running your own node ensures that no one can spy on your transaction. So what I'm trying to say here is that although the blockchain is designed in such a way that anybody can see your transaction, like people can see what's going on in your transaction. But when you run these things yourself, when you run a node by yourself, you can send a transaction to your own node yourself. You can validate your own transaction, in as much as your node is still following the same protocol, the same rule. So that's basically what I'm trying to explain here. So it gives you that privacy and that security here. So the security, in the sense that you can verify your own transaction and blocks following the rule, that's the protocol rule, and you don't need to trust other services for this information. For instance, you don't need to like trust other exchanges for like decentralized exchanges or centralized exchanges for your transactions, right? So once if you're doing this yourself, you have that security or that privacy, and also censorship resistance. Um so running your node ensures that you won't be restricted. For instance, let's say you're using Binance, for instance. Maybe due to government policy, they can suspend Binance, or due to policy change or something can just happen to Binance. But if you're running your own node, you have your own machine, you have your own setup, so you can send your transaction to your node, do the uh, and then your node validates your transactions, add it into the network, and you're good to go. So you're not depending on a third party, to access your data or to validate your transaction. So, and it's still similar to decentralization support. So basically, you're contributing to the network security independently, because as you're participating in this, as you're running your own node, it means you're also ensuring that the network is distributed. For instance, if you're running your own node in Africa, so it means there's a node running in Africa. So it's not like all the whole node is centered in a particular geographical location, maybe, or in a particular continent. So you have it spread out. So it's decentralized. That's the point. So anyone can run, anybody at all can participate in this, in the network, because it's permissionless. And if you want to run a node, you don't need to stake. And what this also means is that you will not earn rewards, because you're not participating in any staking, or you're not participating in any consensus, I would say. So running your own node is basically you're running just the consensus client and execution clients for Ethereum. You're not running the validator client. Uh, we'll still talk more about this eventually.
So-
So
sorry, sir. Can you rephrase back? Like you're saying, running your node means you're participating in. I don't know if you could rephrase that, please.
okay, so what I'm trying to say here is that if you're running a node, just a node, you're only having a consensus client. I'll get to that shortly. So these are, because I stated earlier that running a node means you have certain kind of softwares installed in your system, in your server, or in your machine, in your hardware or your desktop. So those clients, they are softwares basically, and they are called clients. And for Ethereum, because Ethereum now is proof of stake, like the consensus mechanism is proof of stake, so it requires you to run the two clients, to that's the execution client and the consensus client. So if you're running a node, you're only running two of these softwares, the execution client and the consensus client, on your setup, on your system. But if you want to run a validator node, it's still a node, but a validator node is a node that then you're now staking something, so you have that privilege to participate in block validation or proposal. So it means you now have your machine, your setup will now have the power to say, okay, I want to propose a particular block, and I want that block to be added to the blockchain. So you now have power to do some um to participate in block validation and proposals. So what I'm trying to just to clarify, what I'm trying to say here is that if you're running a node, a normal node, you're only running two softwares or two clients. But if you're running a validator node, you're running three clients, and these clients are the consensus clients, execution clients, and the validators clients. So these three clients are what work together for a validator node. But if it's just a node, you're running two, the execution client and the consensus client.
Okay. So it brings me down to another question, right? Which is on the consensus, right? The consensus client you're running. So you mentioned all of this, that you have the chance to have full control over your Ethereum transactions and the rest. On the security level, the security aspect, how do you tend to, you know, make yours secure alone that other people that are running a node are not seeing your transactions? How is that possible? If you initially said that it's just a replica of other systems or other um, transactions that you're seeing on your own end.
Okay, just to clarify on what I said initially. So for the security part, what I meant was if you're running if you're running your own node, you don't need to rely on some centralized exchange like Binance to validate or like to send your transaction. So you can send it to your own node directly, and then your node will do the same, will perform the same function, will validate the transaction.
I don't really know how that works. Is there a way you could throw more light on that? Maybe the example you're giving is not clear enough
We
on
we
my
are we
own.
are going to we are going to get we'll get more in details into that.
So what you're basically doing, right, for running a node, right, aside validation node, you're you just have the chance to like um be in control of your own data, like you're seeing your own data, but you're not really doing anything. Okay, aside you
They
also
can
mentioned participation on the Ethereum network, right? That is
yeah,
you're in a way enhancing the Ethereum network. Or aside that, nothing really. There's really
you
nothing you're doing as running a node, right?
in terms of validating transaction, no.
Okay. That is just like a third one. Do you propose blocks, addition of the block, or is that also included in the validation client?
Sorry, do I propose what?
Are you able to propose the addition of a new block while
No,
running a node?
you can't participate in
Any
any block proposal or attestation for normal nodes. You have to run a validator node to do that.
okay. So what is the idea around the consensus then? You running the consensus client. I think consensus should be like what we agree to, like, I don't know if you're getting what I'm
No,
saying.
there are. I will soon go get to that point, right? So I was going to explain
All right.
different the functionalities, like what each of these clients um what they do basically. So
Okay.
then
All
you
right.
you 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 get more clarity on all of that. Yeah.
Thank you. Thank you.
Is it on me? Oh? Your hand is up.
Okay, yeah, hello, can anybody hear me? Jim.
Yeah, I can hear you.
Okay, okay. Now, I wanted to throw more light when iPhone was asking some questions. So I wanted to help clarify, because there was like a misconception between what she's asking and then what you are answering, right? So the form of you owing your data or you owing whatever you are doing when you are running your node, there may be some misconception around it because it is still a public blockchain, which means that everybody has access to what is going on. But the main concept there that I think that the misconception is coming from is that when you are running this node, you are contributing. That means that this authority that you think others are exercising, you are also in the place to also exercise it in terms of you are also contributing to whatever that is happening, not leaving it to only those. Like if you are not running it, you the auspices is on those that are doing it. But when you are now running it, you are now participating. So I think that is the misconception there about you running your node and then you have every other of your data in your hands without anybody accessing it. And then we can also attribute it to when you buy some visual dedicated server or some private servers. So the details that you are giving there or things that you some may require KYC or some may require some information. So if you are not doing that, then you are doing it on your own solely. All these things you are providing the hardware and software by yourself. That means that all these things are also within your control. So I think that these places may be the places of the misconception between the questions and the answer. I don't know if I'm right, but I'm judging from what I understood from the question he was trying to clarify.
Yes, that's clear. And to add to
Yeah,
what you
thank
just
you.
said, for instance, if let's say if you want to check your transaction, let's say you use Binance or you use any app to to perform any transaction on the blockchain. If you have the transaction hash or you have the contract address, you can query on, maybe you just go to Etherscan for instance and then check, you see some details about that stuff. So what if there is nothing like Etherscan? How can you do that? That's when running your own node plays an important role. So what you just need to do is to query your own node. You can um, just use your from your RPC endpoint. You just check that particular request or that particular transaction from your own node, because your node will be running on a particular endpoint. So from there you can query the blockchain and get that particular transaction. So it's more like you're having control over these things yourself than relying on a service or a party somewhere to perform these things or know more about your data. So that's it. Yeah, thanks for the contribution. So I'm just going to continue with this. So what do you then need to start? What are the basic things you need to set up your, or how can you set up your Ethereum node? So you can use dark node, which is more of a plug and play feature way of setting it up. So that some things like dark node, they are pre-configured Ethereum nodes. So you just require minimal configuration or minimal things that you need to do to set it up. So it doesn't really require much. That's like one day, or you can build it yourself. You can get a custom hardware, or you can get these setups. Basically, setups computers that meet the requirement. Once you have a device that meets that requirement, then you can set it up. But more into that. So the software options for running an Ethereum node. So for the DApp node, which is, so just like I said, they are pre-configured and then they have like certain softwares. So for DApp node, you can also run Gnosis node on DApp node as well. So it's more like you have different softwares in it that you can set up, and they are very easy to configure. So and it presents you with this graphic user interface, that makes it very easy to interact with, unlike interacting or setting these things up using the command line interface. So that node helps you to, it's more like it abstracts all of these complexities. And then there's the CLI, I think that's more like the mostly for advanced users, people that who are very conversant with, or find it really easy to They find it very easy to interact with the command line basically. So like scripting stuff like that. So that's that's another way, and mostly for advanced users. But anybody can do it using the documentation or manual. You just follow the instructions, and you'll be able to set up and install these softwares. You can also use a Raspberry Pi. So these ones they are affordable and basically small computers that can help you to set up these nodes. So yeah, these are like software options that you can deploy or adopt to set up your Ethereum node. And then there are different types of nodes. So basically, how I see this is if you want to look at node from how the way the data are stored, so you can, or the volume of data that is being stored in the particular node. So there's the light node, there's the full node, and then the archive node. So the light node basically stores block headers. So it doesn't really store the entire transaction history. So just the block headers, and from there you can process whatever you want to process. But it relies on the full node for to get more details regarding that data. And then there's the full node. Full node basically stores the entire blockchain history of transactions. So it verifies every new transaction and block. And this requires large amount of storage, let's say from 1 terabyte and more, above 1 terabyte basically. And you would also require significant processing power. And then the archive node, so this basically stores historical data. So if you've been ru- if you've been running, or let's say, okay, I just want to point out, I just want to say it this way. Let's say you built a blockchain 4 years ago, and you went live, and people have been sending transactions for the past 4 years until now. So you can query the entire history from the genesis, from when that blockchain started accepting transactions. So um, the archive node basically stores every historical state of the blockchain since it was um, since it went live. That's since inception basically. And then this type of node requires large amount of storage. So um, so basically, it might not be up to 12 terabytes, but it just requires a very large amount of storage capacity, basically. Yeah, and it's very useful or important if you want to perform, and if you want to do any you want to carry out any research or for analytic purposes. So that's where this mostly comes in handy. Then the hardware requirements and software requirements. So for the CPU, the minimum requirement could be looking at 2 core processor, but 4 core and more is highly recommendable. For the RAM, 8 gig, 16 gig highly recommendable. Storage, look at 1 terabyte SSD. So and let's say two above what's highly recommendable. So basically, all of these requirement depends on the blockchain and also the data it has been processing. So, but blockchains like Ethereum it basically requires significant amount of storage or capacity. And the network is from 10 Mbps download and upload speed, and you need constant power supply. So UPS for backup or solar, you need all of this. Um, yeah, so basically, once you have these requirements properly set up, once you have these requirements, you can you can then start setting up your node. So now I'm going to talk about the clients. Just like I said before, that the clients are basically softwares. They are for your from looking at it from perspective of your just software, normal software. Yeah. So the execution client basically handles the transaction execution part of blockchain, also handles the smart contract processing and your interaction with the EVM. And typical examples of the execution client is the Get, Bisu, Nethermind. So but basically, when Ethereum was using proof of work, really required you only need the execution client to do all of this. But right now, you need the consensus client as well. So the consensus client just helps. It's more like things that involves agreements. So if you're saying this thing is true, how are other people agreeing with you? How are they saying, okay, yeah, 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 we are testing to this and this is valid? So participating in Ethereum's proof of stake mechanism, it helps in the block validation and attestation. And typical examples include the Lighthouse, Prism, and Nimbus. So, but if you now want to run a validator node, then you need the validator client, so which works hand in hand with the consensus client through. Okay, it works with the consensus client to validate blocks and participate in the staking. So, for you to fully set this up, you then have to stake 32 ETH. That's if you want to go solo. So once you stake and do some other configurations, and you're able to set it up, and you then have your validator node set up properly. So how this interacts, this is more like the architecture. Um, so so yeah, just like I said, the execution client now works with the consensus client after the merge. Um, and then the how they interact is through the engine API. So the consensus client, that's the part that handles the consensus logic, fork choice, and block gossip. So it gossips block, like if maybe you need to, if a new block is created, it spreads it across the network that hey, we have a new block. So you just gossip it around. So fork choice, okay, more into that. Um, yeah. So then the execution client, that's the part that handles transactions. It also, you know, when you well, mostly around smart contract interaction and your interaction with EVM. So things like that, it handles. That's the part that handles that takes care of these those processes. So if this is, for instance, the Ethereum network, right? Then, and this is a node having the consensus client and the execution client, and this is another node having the consensus client and execution client. So all of this works in a peer-to-peer manner. So you, as you can see, this interacts with this. You can see the way this node is interacting with this and how this is also interacting with this. So and the like. So even if a new node comes into the network, it also it also follows this protocol, follows the existing rule to to you know um to partic- to perform certain actions. If it's validator node, to then validate transactions and the like. If it's to, yeah, basically that's how each nodes work in the network, how they interact, how they communicate. So just to clarify, the execution clients gossip transactions over the P2P network. So it makes it very easy to manage local transaction pools, and while the consensus client gossips blocks over the network. So this helps. So it helps if then there is need for new block to be added into the network. The blocks get added into the blockchain, and then the chain grows. So that's basically the idea of blockchain, because once, okay, basically a block, okay, blocks handles transactions, like transactions are stored in blocks. Then once the block gets filled, it's then added to the chain, and then there's a link like that, and that's the whole concept of blockchain. So transaction gets added into the block, blocks get added into the chain, the existing chain, or forms the chain, something like that. So yeah, that's basically how the architecture works, how it's been structured. Then, yeah, so more into the clients, the their roles basically. So the execution client, consensus client, and validators client. So in terms of their primary role, the execution client manages states and executes transactions, while the consensus client manages things that has to do with agreement, uh, consensus basically, and block validation. Then the validator client then proposes block and attests to them. So if there is need for a new block to be proposed, is the validator client that proposes that block. And if another node proposes a block and validates that transaction, it's and then that transaction is being gossiped into the network, is the validator client part of that validator node that then attests to those transactions. So in terms of state management, the execution client it manages the state tries and the recept tries. So the state tries basically stores the entire network states. That's things like the account balances, contract storage, amongst others. And the receipt stores the transaction receipts. So this includes logs, the outcomes, and all of these are very important, for verification and querying. So things like events, yeah. So that's like that handles um the execution client is the part that handles things like this. like events basically. Yeah, so it helps in querying the blockchain, while the consensus client manages the beacon state. So be hearing things like beacon chain. So this you're still referring to the consensus client, right? So yeah, but the validator client doesn't manage the state directly because it works in line with the consensus client through the beacon API. I think I didn't mention that, but there's an API that allows these two, the validators client and the consensus client, to work, while the engine API is the part that allows the execution client and consensus client to. So in terms of the data being gossiped, for the execution client is the transactions that are being gossiped across the network, while for consensus clients it's blocks and attestations, while for the validator client is just the attestations. Um, so about the core responsibilities, so the execution client executes or executes transactions and smart contracts. Consensus client runs the fork choice algorithm. So it is just basically an attestation counter just to decide on the particular chain that is valid. That's if maybe something happens along the line. So that's where this fork choice rule comes, because at some point the block will want uh, to achieve finality. Like there just has to be finalization. So um, with the help of the fork choice rule, the blockchain can then finalize the particular data. So yeah, that's just basically what this part does. Then the validators client then proposes new block and votes. So just like I said before, attestation is more like, okay, if you are testing, you're voting, you're saying yeah, you're in support of this, right? So that's basically it. But in terms of interaction with the chain, the execution client creates execution payloads and provides the JSON RPC API. So just like I said before, if you want to like query for a particular transaction, you just need to interact with the execution clients and you're able to get the payload or search through what you want to search, get the data that you're looking for, the transaction. While for the consensus client, so it just tracks finalization and justifications of block. So once a block gets into the blockchain and it is then finalized, once it has attained finality, that means you can't compromise the data, you can't change it, you can't modify anything, except you have to like get all the validators in the network and say we want to change this. So you just need to get above 50%, I would say, of all the nodes to agree on that before you can then decide. But once finality is reached, it's almost impossible. In short, I would say it's impossible to change anything on the transact on the blockchain. So it's not like, okay, for me personally, how I see this thing is, it's not like, when people say they can't change things on the blockchain, it's not like it's not possible. It's possible, but it's difficult because you can't get trying to get all the node in a network to agree that you want to change these things. If you're in a stadium or something, you're trying, you want everybody to decide, okay, this is the road we should follow. So people are just naturally stubborn. Like, you tell them what, that okay, this is the plan you want us to this is what you want us to do, what we should do, and they decide not to do it because they don't feel like okay they are satisfied enough. So, but this that's like by the way. So the idea here is that it's very difficult once something has been once finality has been reached. It's very difficult to make any modification on the network. So yeah, for the validator part, so the interaction with the chain is the part where you then have to stake your ETH and then you earn reward or you get slashed. So that's like the part that does that. So and then lastly on this part, so required when you're looking at the part that is required for the Ethereum's proof of stake. Execution client is essential for execution layer. Consensus client is essential for consensus and proof of stake participation, while the validators client is essential for validating blocks and ensuring network consensus. So that's basically this is basically their responsibilities of what they do, and I believe with this you have more clarity as to we why you need all of these clients. So because they have like specific features and implementation, so they have to like work together according to the protocol. So sometimes when I say protocol, I also mean rule. So just I tend to use both interchangeably. So basically that's so for today this is I believe this would give us a basic understanding of how we can run an Ethereum node, looking at considering the things that are required in terms of hardware requirements, software requirements, client requirements, client in the sense that the softwares you need to install, and also how you can set all of these things if you want to set it up, if you just need like a plug and play, or you want to do all of these things using CLI. So more we are going to okay tomorrow. So basically what we'll do tomorrow, we are going to do a little bit of practical to show us these things, how especially setting it up, like preparing our operating system, and also ensuring that our device meets these requirements. So we just need to like have those setups, prepare the basic things like the OS Ubuntu, for instance, having it up, and then installing the client, get you want to install, and the like. So things like that we are going to do we are going to see how these things work in the next class, and also how and then discuss about DVT. So DVT is more like it's a I will just call it a setup that makes it very easy to like eliminate um it's more like a redundancy setup that tries to prevent this single point of failure kind of thing. I don't know if that makes sense, but if you have a setup that has, if one thing fails, then that system would have an issue. Like if for instance there's just one validator client setup in your validator set that is running, if that validator setup fails or if anything happens to the validator client, then you know your node is in danger or you'll be slashed. But if you're running a DVT, you then have a setup that even though one of the number of setups that you have goes down, it doesn't cause any issue unless maybe a particular threshold value is down. Let's say your setup is requires that 3/4 of your validators are active. If anything below that happens, then you'll be prone to slashing or setting penalties. But just to like avoid being overly complex with my terminologies, we are going to like have hands-on experience or hands-on sessions on this for more clarity and also for better understanding. But basically, if you have any question, you can ask. I just hope I'm not too fast, or I hope I was able to
Hello,
carry on.
good evening.
Yeah, good evening,
Yeah,
brother.
yes. I actually wanted to ask a question before, but I was in a noisy environment, so I was unable to on my mic. And is the question is about when you are saying that we can actually run a node without staking. So, what will be the reward for running a node without staking? That is my question.
Okay, so if you want to run the node, you just need the two soft. Okay, sorry, you're talking in terms of reward.
Yeah, is there any reward
Okay,
for
basically,
running a
basically,
node?
no reward for you, like in terms of, but the reward generally is you're ensuring that the network is stable, you're ensuring it's stronger, it's more decentralized, but it's more like from a protocol point, you're just ensuring that the network is robust, but you're not earning anything for participating except you're running a validator node.
All right.
Okay. Okay, so is there any other question?
Hello. So the other guy said the other day that we really don't need the 32 it to run a node. I really don't know if there's no reward for running the consensus and the execution node. Then what's really the incentive, or is it that maybe you can
Yeah.
get one or two persons to maybe pool funds together and do it, or what's really the incentive apart from securing the protocol and all that? Is there any other benefit, maybe because of the security and maybe helping you to be in charge of your own personal transactions and all that? Is there any other incentive? Or is there any other way to run a validator node? Or can you like leverage on maybe some other big third party or something to participate in this validator node?
Okay. Yeah. Yeah. That's a great question, and yeah. So basically, you can actually run a validator node without having the 32 ETH. So if you want to be like a solo staker, that's when you need the 32 ETH. But if you don't want to go through that route, there are lots of protocols that are making it very easy, because that's a huge barrier to entry for someone who just wants to um, participate, who wants to run a validator node. Um, so there are protocols or there are innovations like the Lido CSM. It's more like a community staking module where you don't really need as much as 32 ETH. So I think it's around 2 ETH or so, or 1 point something. Uh, I can't really say the exact stuff, not the exact amount of ETH, but basically you just need as low as 2 ETH to participate. Um, and what they do is they make it very easy for anybody to start, to start validating transaction, to start participating, to start running a validator node and still earning from you. So that's one way.
Even
Yes.
even as even as low as that,
Huh?
because I'm actually just getting this update. This update you just mentioned is the first time I'm hearing it. I was thinking it's only solo approach into staking, like being a validator.
Okay,
I didn't
no.
know there were really approaches like this where they try to make it the barest minimum. How do they go around it? Is this something you can share, or is this something you share maybe later on in the bootcamp?
Yeah, let me see how I can Lido CSM, just see the check online, but let me just see if I can get the link. So it's but do you know of Lido?
I've heard that word once before. I think um, one of the lectures that was hosted at Cafe One. I think KCP was there, but I really didn't really show more light on it. I don't know. It's just for the first time I'm hearing the slash breakdown. I
Okay.
usually put it.
So I just dropped the a link to their doc. You can read about it, and that's the link to their documentation, to the module. So if you read about it, you have more clarity on that. But it just if you need more insight on how to set it up, we have people that can help you on that. That's really not an issue. And there's Rocket Pool. There are others too that just tend to pull if together, help you stay. So if, for instance, me one person, anybody that has 32 hits and willing to stake, you can use DVT, and what you just need to do is just have the DVT running on your own machine, and you're also participating in the network. So it's more like a cluster based approach. So is there any other question, clarity, you need clarification on something?
Okay, guys, nobody has a question. I don't think anybody has a question. Thank you very much, Alison. Really appreciate it. Okay, so see you on Wednesday, guys. Our practicals are coming soon. Yeah, start pushing practicals. Get your laptop ready, get everything ready. And, looking forward to building together. Have a lovely one, guys.